laptop, you know.
Project on the wall.
Come over! Look what we're doing. Right, so what's the story? A man is standing at the top of the tower, as you do, and he throws a ball, as you do, above the ground. This is B2. Let's fly through it and finish on B2. Right, Tekken. Here's the ground. How tall is the tower?
13.4 meters.
This is 30.4. And what angle does he throw it at?
35.
And what speed? Don't know? We'll call it U then. And what else are you told, or is that it?
The maximum height from above the ground is 45.5 meters.
You know that it reaches a height of, say again?
45.5.
Right, so is the question, and is that all you know?
Yes.
What's the speed?
We don't.
We don't. Right. Vertically, U-V-A-T-S. What's the U? Vertically.
It's a U sign.
Well, no, it's U sine 35. The V, if I'm looking up to here, 0. The A, minus 9.81. The T, yeah, no. You're not doing it right, second. I want the start, not the end. And the S, we do know. What is it?
45.
No.
Minus 45.
No.
Minus 15.
No. What is it?
15.
15.1.
Why?
Because this is the ground level. This is the or axis. Oh, darn. Oh. Right, so what can we use here? What about V squared equals U squared plus 2AF? V squared equals U squared plus 2AS. 2AS. So when you solve this, you get U equals 30 meters per second. What's his answer?
30.
Great. Now let's get the time it takes to hit the ground. So again, vertically, U equals 30 sine 35. V we don't know. A minus 9.81. T we don't know, and S minus 30.4. And what do we want? The T. S equals U, which is 30 sine 35. Yeah.
Why did you put V equals to 0?
I didn't.
No, I wonder why you did it.
Because now it's the time to hit the ground.
Oh.
So S equals UT plus a half a t squared. So you get 4.905 t squared minus 17.2 t minus 30.40 equals 0. What type of equation is this? Quadratic. What should we use here? We should use the formula, right? Yeah. There will be two answers, one positive, one negative, except only the positive answer in this case. 4.8, is that correct, KJ?
Yes.
Right, what's next?
You tell me the horizontal distance traveled by both ways.
Right, so horizontally, U equals 30 cos 35. V, we don't know. A is 0. T, we do know. S is what we want. So S equals UT plus a half AT squared, but the A is 0. So it'll just be, my last answer, no, it'll be 30 cos 35 times 4.8, and I get the range is 117.9, so 118 meters. Correct? Yes. And then, what's the velocity of the ball just before it hits the ground? Well, it's the kinetic energy at the start plus the potential energy at the start equals the kinetic energy at the end. What's the mass of the ball? Do we know? We don't. So it's m. What's the starting velocity? 30. So squared, 900. mg, and what's the starting height above the ground?
30.4.
And then the kinetic energy at the end is a half mv squared. So the m's cancel, and you get 450 plus 30.4 g is a half v squared. So I don't want to be surprised. I want to know if I'm right. I need this. .7 meters per second. What's the answer, KJ?
30.1.
Nah, that's not.
Okay, 27.
Right, that's the A part only. Now look at the impossible B part, is it?
I think we've done.
Not quite.
For example, even tell you what to find. For the vertical component, horizontal component.
Determine the vertical component of the force of the ground on the ladder. Is there friction?
Frictionless reciprocal.
So they want the horizontal and vertical forces at the base of the ladder, basically. Right, let's draw this. Okay, so tell me, KJ, do we know the length of the ladder?
Yes.
What is its length?
4.5.
4.5 meters. And what else do we know?
We know the mass. Ladder.
What is it?
20.5.
Okay, so there's a weight here of 20.5 G, and there's another force here, isn't there?
Yes, 80.
What is it?
80 kilograms.
80 G. And there's a force against the wall here, which I'll call S, and there is a reaction force which is at an angle, which I'll call R, and they are looking for the horizontal and the vertical component of this force. Now, we don't know the angle this is at, but we can know the angle maybe of the ladder, because we know that it's 1.8 here and 4.5 there. So, not tan, I don't think.
Sine. No, sorry. Cos.
We'll get there eventually.
Cos.
Theta is cos inverse 1.8 over 4.5. 66.42. Now, do we know where this is placed?
Yes. 0.8.
From the top. So this is a point,
Yes.
this is a 0.8 distance here. And what's this distance then? Well, the total has to be 2.25.
Why?
Because it's in the middle. So,
Oh.
so this has to be a 1.45. Yeah?
What do you mean that for?
Turning forces.
Oh.
I know. No. Where, oh where to take our turning point? I know this is going to be long and it's making me feel sad looking at it. I'm going to do something crazy. Hey, I'm going to see craziness happen right now, okay? I'm going to go to the side. No, look at the craziness. People, please, craziness. Right. So this weight, how far away was it? 2.25. And then the other one, how far away was it? 0.8. I want to replace the two of these with just one force. So how big is this one? This was 20.5 G, and this one here 80 G. So if I was to replace with one equivalent force, it would have to be 100.5 G. But where do I put it? I don't put it here. I don't put it here. Where would it have to be? Somewhere in the middle. Where in the middle? Well, you would want the turning force to be the same. Yeah? So, this distance here and this distance here, what are they? Well, this would be 0.8 cos theta, which we know, and this distance here would be 0.225 sine theta. So you can have 80G times 0.8 cos theta plus 20.5G, I'll call this here L. Why did I say cos, sine? Sorry, that's cos as well. 20.5G cos theta. That must equal 100.5G times L. And here, sorry, this should be 2.25 cos theta. Okay. So can you get the L here?
Yes.
You can. Let's just type it in. What was the angle for the ladder? What is the theta? Can you give it back to me?
6.42.
Okay, thank you. $80 times 9.81 times 0.8 times cos theta plus 20.5 times 9.8 times 2.25 times cos 66.42. Yes? Divided by 100.5 times 9.81. Super wrong. Wait, no. I must have typed something in wrong. 80 G 0.8 cos theta is 20.5 times 9.81 times all over 100.5. I typed 10.5. That's right. Right, the L is 0.439. Yeah? So you could work out this distance now because we know this distance. You can say cos 66.42 equals 0.439 over x. So x would be 0.439 divided by cos 66.42. So this distance is 1.1 meters. Now let's go back. Yeah, you're like, so where's this dude going with this? Right, so if I go back to my ladder, let's redraw it. Instead of having two forces, I only have one force. How big is this? 100.5 G. Here is S, and here is R. How many forces are on this?
3.
So My magic allows me to do what now?
Resolve.
No?
Draw your point. Join them.
No. I can now use the three-force theorem.
Oh, that's it. Join them.
Okay. The three-force theorem says what? That
meet at the point.
they all meet, oh that's ugly, they all meet at the same point. Okay. Right. We know this angle. Oh dear, we're running out of time. We know this angle? Oh, my pen stopped working. Come on. We know this angle. We know this angle. It's the same as this one. Yes? What else do we know? Yeah, we know this length here, don't we? Yeah. I really want to get this angle. Can we?
Cos.
I know this. I know this distance.
Yes.
I know this distance. I know this distance. I know this distance. Yeah, I have enough. Look. I know this distance. Yes?
Yes.
Because I know this distance. I know this distance. So can I know this distance? Yeah, I'm just using Pythagoras. So I know the three distances here. So do I know this distance? Yes. Can I know this distance?
Yes.
It's the total minus that one. So I have these two distances. Yeah? Can I know this angle?
Yes. It's
Can
the
I?
same.
Yeah. So do I know this angle?
Yes. 995.
Do I know this angle?
Yes. Definitely. 189.
Yeah. So I have the two distances and this angle here. So can I know this angle?
Yes. Cos. No sine.
No.
No.
Well, if I know this side and this side and this angle, can I know this distance?
Yes.
Yeah, using the cos rule. So I have the three sides and one of the angles, so I can use the sine rule
Yes.
to get the other two angles. So now I know this angle here after all of that. So this will be or cos that angle, and this here will be or sine that angle. But I know what or sine should equal. It should equal the total downward weight, which is 100.5. So can I know what the or is if I know the alpha? Can I? I can. If I know sine alpha, can I know the or? I know the or. If I know the or, and I know the alpha, can I know the or cos alpha?
Yes.
And then it's finished. So I didn't have time to do all the steps, but at least I could outline the process involved. It's long. In fact, for 8 marks, is it worth your effort? Do you think so, for 8 marks? Like, I mean, would you not be better doing a different question from section B? I don't know.
Yeah, skip that.
So can you at least just write down, we can continue it later, but the thing that we really need to use later is this length here,
That's 0.4.
439. I'll need to, that this is 1.1 and this is 0.439, and then we'll use Pythagoras really quickly. 1.1 squared minus 0.439 squared. So this side is 1. Okay, later today we'll finish the question. Okay, and then how many does that leave?